The last of these trig formulas that we're going to look at. Products to sums and also sums to products. So let's start with products to sum. So if we get a product, and in this case it's a cosine times a cosine. So 2 cos A cos B would be cos A minus B plus cos A plus B. But basically it's coming from the cos compound angle formula, because the cos would go cos cos sine sine. But I'm only left with the cos cos. So the sine sines must have cancelled out. Now, because one of them is plus sine sine and one of them is minus sine sine, I must have added them together to cancel out the sine sine. So that's where it comes from. So 2 cos A cos B would be cos A minus B plus cos A plus B. Now, if it was sine cos, then it must have come from the sine compound angle formula. So sine cos, cos sine. In this case, it's the cos sine that's cancelled out. But same reasoning, it would be plus, because one of them was plus cos sine and one of them was minus cos sine. And then there's this third one. What happens if we get sine sine? Well, that must have come from the cosine one, but now it's the cos cos that's cancelling out. So I must have subtracted them. So I ended up with the sine sine minus minus sine sine. They're the formulas. Let's use one. If we have to express as a sum or difference of these trig functions. So I've got 2 cos 5x sine x. So it's cos sine, but I tend to remember it as sine cos rather than cos sine. So I'm just going to rearrange that. So it's in that form sine cos. So now because it's sine cos, I know the cos sines cancelled out, so it must have been the sine, the difference of the two angles, plus the sine, the sum of the two angles. So I get sine negative 4x plus sine x, but sine of course is an odd function, so I can rewrite that as minus sine 4x plus sine 6x. Cos cos, well cos cos must have come from the cos formula. It's the sine sines that have cancelled out, so I'm adding the coses together. So I get, well, a half of, that's where I've got to be careful, because my formula is for 2 cos cos, so I've got a half of that. So I'll get a half the cos of the difference plus the cos of the sum. Now, because it was plus, it didn't actually matter which order I put them in, so I actually put the sum there first. 5 and 3 is 8. Cos minus 2 theta, but cos is an even function, so cos of minus 2 theta would be the same as cos 2 theta. So I now have to work out 2 sine 45 cos 15. Well, the sine 45 is not a problem because we know that's 1 on root 2. But cos 15, unless I want to actually go and work out what cos 15 is, I've got a problem. Now I don't want to waste time working out cos of 15 because I'm going to have to use a formula for that anyway. So I may as well use the sine cos. So 2 sine cos must have come from the sine one. So I've got the sine, the difference of those two angles, plus the sine, the sum of those two angles, and I end up with 2 exact ratios that I know. So sine 30 plus sine 60, a half plus root 3 on 2, I get 1 plus root 3 on 2. Prove sine squared 5 theta minus sine squared 3 theta is equal to sine 8 theta sine 2 theta. Now this is one where it's unusual because normally we would start with the left hand side. Well, you don't have to. Quite okay to start with the right hand side, and that's what I'm going to do. I'm going to start with the right hand side because I had this formula to convert this product into a sum. Well, in this case it ends up being a difference. But I'll get a half of, because my formula, remember, is 2 sine sine. Must have come from the cos formula, but in this case it's the cos coses that are cancelling, so I'm going to subtract the 2. So I've got cos, the difference of the 2, minus cos, the sum of the 2. 8 minus 2 theta is 6 theta, 8 plus 2 theta is 10 theta. Not quite there. But now I'm going to use my double angle formulas, and that's how I'll create the squares. So one way we could have written cos double angle was 1 minus, in this case, 2 sine squared 3 theta for the first one, and 2 sine squared 5 theta for the second one. The 1 minus 1 goes away, and I end up with the result that they're looking for. Sine squared 5 theta minus sine squared 3 theta. Well, that was products to sums. sums to products, if we want to go back the other way, here's the formula. Sine A plus sine B. We get 2 sine half A plus B cos half A minus B. Well, that's hard to remember, so that's how I remember it. 2 sine half sum cos half diff. So 2 sine half sum cos half diff. How I remember it, I'll do the other ones and then explain the pattern. What if it's cos plus cos? We get 2 cos half A plus B cos half A minus B. 2 cos half sum cos half diff. So you notice they both finish with cos half diff. They both start with 2, and the first one, when it was sine plus sine, it's sine half sum, and when it was cos plus cos, it's cos half sum. So 2 sine half sum cos half diff, 2 cos half sum cos half diff. Then we get cos minus cos. This is where I say to myself, well, that's a bit different. Instead of plus, it's a minus. That's a bit different. So my formula ends up being a bit different. The others were positive, so it's a bit different. This one's minus. So I'll start with minus. That's a bit different. Minus 2. I've got cos, and normally I would start with the same ratio, but this one's a bit different. So I'll start with the sine ratio rather than the cosine ratio. And this is a bit different, so I'm not going to finish with cos, I'm going to finish with sine. It's a bit different. So in my head I'm going, oh, this is a bit different because it's minus. This is a bit different. So I make everything different. So I go minus 2 instead of plus 2. I'll go sine, even though it's cos I'm finding, and I'll finish with sine rather than cos. Yeah, I know, it's just how my mind works. You wouldn't want to be in there, trust me, it's weird. Okay, let's do this one then. We're going to prove cos 75 plus cos 15 over sine 75 minus sine 15 is root 3. Okay, well, the first thing I've got to do, because you'll notice I don't have a formula, well, I don't bother remembering one anyway, for sine minus sine. And the reason I do that is because I can turn it into a sine plus sine by taking advantage of an odd function. So that way I only have to remember the one formula. So I change this sine 75 minus sine 15 to sine 75 plus the sine of minus 15. So on the top now, I've got the sum of these two coses. So that's 2 cos half sum, cos half diff. So sum of them, 75 and 15 is 90, the difference is 60. On the bottom, I've got the sum of 2 sines, so that's 2 sine half sum, cos half diff. Now we just got to work out these exact ratios. When I look at this fraction, I've got cos half 90 in both of them. They will cancel straight away. The 2's cancel. So I've got cos 30 on sine 30, which is of course cot 30, it's upside down. So we get the square root of 3 as our answer. Say I had to solve this equation. Sine x plus sine 3x is equal to 0. The angles are not the same, makes it a bit awkward. But what I can do, because it's equaling 0, and just like in quadratic formulas, when you've got two things that multiply together to equal 0, one of those things must be 0. So if I can turn this sum into a product, I'm going to have a much easier equation to solve. So sine x plus sine 3x. Well, it's sine plus sine. So that's 2 sine, half the sum. Well, 3x and x is 4x, half of that is 2x. Cos half the diff. X minus 3x is minus 2x, half of that is minus x. But of course cos x is an even function, and so I get sine 2x cos x. So either sine 2x is equal to 0, cos x is equal to 0, and when you talk about sine and cosine, and tan for that matter, equaling 0, they're very easy ones to solve because they're just boundary values. So sine 2x, I'm going around the circle twice though. So I'll have 0, 180, 360, 540, 720. Divide each of those by 2, so I've got all those possibilities. Cos x equals 0, only going around once this time. I've got 90 and 270. Well, I already got those answers anyway, but it was still important to check in case we created new answers. And so there's my solution to the equation. 0, 90, 180, 270, and 360. Okay, 17G we shall do.